So, hello, everybody, and welcome to What Do Scientists Do? It's a show where I talk to a different science guest each episode, and they tell us all about their lives and their jobs working in the fields of science, technology, engineering, and math. My name is Jessica, and today I'm joined by our very special guest. Could you give us your name and your pronouns, please?
Hey, my name is Bas de Bruijne. My pronouns are he, him, and I'm here to talk about software engineering.
Cool. So, what is a software engineer?
Ooh, yeah, good question. There's a big range of people who use software. A lot of scientists use it for like the research that they do, doing all kinds of complicated calculations, or other engineers would use simulation software to make sure that everything is working, like mechanical engineers or other type of engineers. I think software engineers are the people who build the tooling and infrastructure to allow other people to do with the code or with the programming what they need to do to get their job done.
So, could you give me an example of something that like a software engineer might do?
So what I do specifically is in my job I make cloud infrastructure. Yeah, so like when you log into to a server with your computer or with your phone, all the data that you receive has to come from somewhere else. And it's pretty complicated trying to like make sure that every time you send a request, there is somewhere a computer available to respond to it. Um, and to make sure it's not overloaded by all the other people trying to get the same website. Um, there has to be a database connected to it to make sure that all the data that you receive is actually available. And my job is about designing those infrastructures and making sure that all the tools that we use in there work together, um, and then help our customers set up their websites and stuff.
So, you help make it possible for somebody to go to a website and for the computer to actually get all that information from wherever it's stored and get it back to you. And I assume there's a lot of steps along the way, and you have to
Exactly.
kind of
Yeah.
make those steps and figure out those
Yeah.
steps.
Yeah. Yeah.
Cool.
Exactly.
How did you decide that you wanted to go into software engineering?
So the decision I made is after I graduated. I originally studied mechanical engineering, um, and I think I started mechanical because I didn't really know what I really wanted to do, and I was like playing with Legos. Um, and like as I mentioned before, a lot of scientists also have mechanical engineers, or later I did more like robotics. They use programming for everything that they need to get done. So there I got a lot of exposure to more the software engineering world, and I found out that I really liked it. And then I got a job as a software engineer, and I'm still liking it.
Well, what do you think makes someone a good software engineer?
That is a good question. So for one, I think it's important that you know how to code. Why? So code is it's just like typing stuff on a computer, of course. Um, but it's very important to know what kind of functions are available to you to get different things done, and to know how those functions will fit together and what will be the best way to orchestrate that to get your problem done. But there's also like the bigger picture aspect, like with any job, that you need to have a good way to finding a solution and finding the ways in which you know that your solution is good.
Yeah, so like being someone who likes to kind of solve problems and like test their solutions and has like the patience to test the solutions and stuff like that.
Yeah, exactly. Yeah. And then when you after you test everything, you can sit down again and try to find the best solution of all your tests. And that's how you get good software. Yeah.
Cool. Do you have a favorite science or engineering related thing that you've ever done, whether it was with software engineering or engineering in general?
Well, I can talk about a fun project that I did a couple of years ago, which is also very much software related. So I did a project on telescopes correcting images that your telescope receives. So, like when you look at stars, they twinkle, right? Have you ever heard of why they are twinkling?
I don't think so. What's that?
Okay, so the stars twinkle because the atmosphere that is between us, there are like clouds in the atmosphere, but even like differences in pressure and humidity, even if you can't see the clouds. Um, and all those differences diffract the light in a bit of a different way. And when all those clouds go by, the way that your light is deformed changes every millisecond. Um, and then to your eyes, it just looks like the star is twinkling. But actually, the star is standing perfectly still, but the atmosphere in between us and the star is twinkling. And there are very fancy telescopes who can actually measure what this how the atmosphere has deformed the light that's coming from the star. And then when you measure it, you can do a lot of calculations on those measurements, and then try to estimate what the star looked like before it actually entered the atmosphere. And that's something that is done in a lot of big telescopes already that are not like the James Webb Space Telescope, because that's on the other side of the atmosphere, but all the telescopes that are on Earth do that. And I did research on like trying to find a better way of getting the sensor data out of one very specific sensor in a big telescope. So it's very much a small piece in a very big puzzle, but it's very nice to work on.
That's cool. I love that. There's something very cool about being able to potentially look up at the sky and see what's actually there, like trying your best to see what the space telescopes would see, only you're seeing them from the Earth. So, in theory, if you had a fancy enough telescope on Earth, you could see stuff just as well as if you were out in outer space, right? If
Exactly.
everything was
Yeah.
perfect.
If everyone was perfect. Everything is not perfect, unfortunately. But yes, it is nice to get. And well, you can get it better in different ways because it's very expensive to get a telescope in space. So you can make a telescope that is much heavier, and like the lenses can be much more big and complicated, because you don't have to put it on a rocket. So in that way, in different ways, you can get better images than what you can get in outer space, but they both have their own use case, of course.
That makes sense.
Yeah.
And that's what engineers are for, right? Is
Yes,
solving all
exactly.
those problems and finding all those solutions and making the technology better and better.
Yeah, exactly. Yeah.
Cool. Do you have any advice for kids or young adults who might be interested in becoming software engineers or engineers in general?
So software engineers specifically, um, like if I think back about what I did when I was a kid, that might have been a sign to me that I should go into software engineering, is that I always like playing with my computer and trying to like get my computer to do my math homework for me, which was very nice back then, but also it taught me like the basics of programming, which is very nice. So if you're a kid and you want to go into programming, the best way is to just get started, which sounds hard, and it definitely is very hard when you are beginning. But if you think that kind of stuff is fun, then it is definitely something that you can enjoy spending time on. And I think that's with all types of engineering. Like if you want to go into mechanical, you can try building stuff, and you don't even need to choose your direction first. So you can just do what you want and you think is fun, and maybe you're lucky and there's a whole field of engineering related to it.
Well, like Legos and mechanical engineering, right? I mean,
Exactly. Yeah.
I feel like mechanical is probably what a lot of kids think of when they think of engineering, like building cars and buildings and boats and like mostly things with moving parts, right? But engineering is
Yeah,
just anything where you're trying to make new technology or improve technology in order to solve a problem.
yeah.
Did you ever play with Scratch as a kid or as an adult?
I did a little bit in high school. Yeah. It is. Well, I was talking before about the different building blocks that make up code. I think Scratch does really an excellent job of visualizing what those building blocks are and making a nice interface around it to make it easy for people to understand what's happening. And really, if you compare Scratch code to a code that you would see on my screen, the only difference is that it's not colored in with nice big bright blocks. But otherwise, it's really very similar. Um, and the nice thing is that Scratch also makes it very easy to make more graphical tools. So for me in the server world, I just look at black screens with green text on it all day, and I don't see anything else that is fun in that sense. But Scratch does a really good job of trying to make a visual product out of it and give it to you very quickly.
Yeah, we use Scratch a lot at Supernova because we run our computer science camps and workshops and things like that. And that's something that's
Yeah,
easy for me to just send the link to people. So I'll link that in the episode description because it's a fun way to
yeah,
start
nice, good
coding
idea.
if you've never ever coded before. Cool. Are you and if you're not able to talk about this, that's okay. But are you
Yeah.
able to describe the kinds of anything specific about what you're working on right now or like problems you're trying to solve?
Yes. Most of the things that we're trying to solve is like the servers that you interact with, and the server is just a computer that is somewhere else. Um, you always want them to be like ready when you are ready, and for that we are working a lot with virtual machines. So like your laptop, it like freezes sometimes, and it maybe you deleted the file that you weren't supposed to delete, and now it doesn't turn on anymore. So that also happens to servers, of course. They also freeze and they also break sometimes, and that's why we use virtual machines, which are just smaller machines they're kind of fake machines in the sense that they don't have a power button, but they live inside a different computer. And because they live inside a different computer, they're all made of software. So if they freeze, you can just delete your whole computer and start over. And that's what we do. Most of the products that we make are ways to get these virtual machines on your physical servers. And there are all different types. Like if you know you're running a web server that just needs the two programs, you don't maybe need to install a whole operating on your virtual machine, but just the two programs that you need. Or maybe if you like want to provide every kid in your whole school with a computer, then you do want to have like the whole operating system on there just to make sure that all the tools that everyone in the high school uses are available to them. So yeah, there are very many different ways to do that, and we try to like make sure that they all work and that everyone who has a specific use case also has like a good type of virtual machine to work for them.
Cool. So it's like instead of your computer communicating with like a physical machine where if a part breaks, the machine breaks, it's communicating with a computer that has a machine with like a code machine within it
Yeah,
that won't
exactly.
break.
Yeah.
Like
So it's
I guess
like
the computer could still break, but
yeah. So if your main computer could still break, and then if that happens, then all your virtual computers also break. But the chance of that happening is very low because your main computer only has one program running, which is the program that makes all the virtual computers. Um,
mm,
so as long as you got that one program right, you can be pretty sure that at least you don't break everything. You might just break one of your virtual computers.
That makes sense. So it's definitely far fewer things that could break compared to like if you have to replace parts or if there's like power surges and all sorts of things that could harm a physical server.
Yeah, and there's also virtual harm, of course. Like maybe there's a hacker who has gotten into your server, which would be very bad, of course, if it like tries to steal your data. If all your computers are virtual, you can just delete the one computer that your hacker is in and start over, and then they are out of your system.
Oh, that's very cool actually. I've definitely
Yeah.
heard the word virtual machine before, but I didn't know what it meant. So
Yeah.
I'm learning a lot today.
Nice.
Yeah. I feel like it's just like a thing that I've heard and that's all.
Yeah. And
Cool.
it is a bit weird to imagine that like it's a computer, but it's like not a real computer. But it is very helpful.
Yeah, it's like a computer within a computer, like
Exactly. Yeah, you
it's
can have
weird to wrap your
multiple
brain
layers
around.
of it. You can have virtual machines running on other virtual machines, if that is something that you need.
Oh my goodness. So if virtual machines can be this helpful, why do some things still even bother having regular servers?
Well, you still need the regular servers to run your virtual machine on. But you can see it also like in the physical in the personal technology world, where before the only option if you wanted to game was to buy a computer that could run the games. But we're also starting to see now services that are providing gaming in the cloud, that your computer just connects to this virtual machine that someone else is running for you. And then you don't need to buy an expensive computer yourself to run those games. But there is, of course, a bit of loss in performance to if you run virtual machines. And it's small enough that it doesn't really matter in the personal world, in the server world. But like your phone doesn't have that much computing power left over after it's running all your apps. So it's better to just keep your phone and your laptop running as non-virtual machines.
That makes sense. Well, this was very cool. I didn't know what virtual machines were before this. Do you have anything that you would like to promote?
I think just promoting Supernova is nice.
Yeah, we can promote Supernova. Supernova runs computer science camps. We also run engineering camps. This would probably be more related to computer science, but I mean, it's computer science and engineering. We also run science and oceans camps. And for middle school ages, we specifically have engineering design camps this summer, as well as advanced coding camps. If that's something that anybody's interested in, those are happening in Halifax. We also have like online resources. I'll post a link to Scratch. And yeah, by the time this episode comes out, registration should be open for those camps if that's something that you're interested in. Thank you so much for joining me today, Bas.
Yes, thanks for having me. It was very fun talking with you.
And as always, a big thank you to everybody listening. Do you have a question that you'd like answered by an expert? Send us an email or a voice recording at whatdoscientistsdo@superstaff.ca. For more science fun, you can also follow us on social media at ScientistsDoPod on Twitter and Instagram. Thank you so much for listening, and I'll see you next episode. Bye for now! This podcast was made by Supernova at Dalhousie University, a network member of Actua. For more information on our summer camps, workshops, and more, check out supernova.dal.ca.